YouTube, Sandra here again. This is going to be yet another debunking video, and this video that I'm debunking, it's another one of those videos that I was supposed to debunk, I think years ago, but I just never got around to it, so I'm doing it now instead. And yeah, it's a video that claims that evolution is a bunch of hogwash. Let's dive in.
Evolution. It's not a scientific law or a law of biology. A scientific law must be 100% correct.
Yes, evolution is technically speaking not a law. It's a theory. So you're technically correct, I guess, so far.
Failure to meet only one challenge proves a law is wrong.
Okay, so this is another one of those cases where someone doesn't understand the difference between hypotheses, theories, and laws. So let me just break down what an actual theory and a law is. You see, a theory is simply something that used to be a hypothesis, but it has withstood falsification an enormous amount of times. You see, in science, we don't really prove anything. We try to disprove things. And if something fails to be disproven after we have, without mercy tried to absolutely disprove something over and over again, then that hypothesis may be raised to the status of a theory. So a theory is not something that we have technically proven per se, it's just that it's been failed to be disproven so many times that, well, it is a very close approximation of reality, basically. And that's what's happened with evolution. It started out as a hypothesis, and we've tried over, a century now to disprove it over and over again. In a laboratory setting, we've also tried to disprove it in the wild, and it just fails to be disproven. So our modern understanding of the theory of evolution, it's a very close approximation to reality, and it does allow us to make predictions of what we would expect in certain environments and if an organism reproduces over several generations. How will they evolve over time? We can make predictions and see that in many cases our predictions turn out true. A law is basically the way in which we have compartmentalized and described a phenomena that we witness under circumstances. For instance, you have the law of gravity, meaning that if you drop something, it's going to fall down to the center of mass of the object that we call Earth, for instance. We also have the theory of gravity, which describes how this works. And, there's different models you can use. You can look at relativity, for instance, which so far is the most accurate model we have, where gravity is the byproduct of the bending of space-time due to mass. According to quantum field theory, there might be a particle associated to gravity called a graviton, just like you have with the photon, which is the particle of electromagnetism, for instance. But so far we have not detected this particle. But the point is, laws are simply phenomena that we have been able to define and compartmentalize into criteria of something that we witness happening. A theory is a way that we describe and explain what we witness.
The process of natural selection is not an evolutionary process. DNA proves that evolution is false. The DNA in plants and animals allows selective breeding to achieve desired results. Dogs are a good example of selective breeding. The DNA in all dogs has many recessive traits. A desired trait can be produced in dogs by selecting dogs with a particular trait to produce offspring with that trait. This specialized selective breeding can continue for generation after generation until a breed of dog is developed. Many different types of dogs can be developed this way. but they can never develop a cat by selective breeding dogs.
Yeah, that's not how evolution works, okay? You see, this is a very common misconception with creationists. You've probably heard this age-old argument now. Well, my daddy didn't come from no monkey. You know, basically the idea that, hey, you don't see monkeys giving birth to humans, so obviously evolution can't be true. You see, the thing is, monkeys give rise to monkeys. Humans give rise to humans, okay? That's how evolution works, because evolution doesn't really operate in the microscale of a generation, let's say. You're hardly going to see any change whatsoever in speciation in one generation. Okay, it's going to happen over, you know, hundreds of generations at least. The reason that we can view evolution much faster in bacteria, for instance, compared to, let's say, chimpanzees, is because bacteria go through multiple generations very quickly. Okay? Within a single day, you can have multiple generations of bacteria arising. And that means that since you have so many generations arising, you're going to see a faster rate of adaptation and as such evolution. That is why, for instance, it didn't take very long at all in the grand scheme of things for bacteria to start to develop resistance to antibiotics. Only a few decades, really, compared to how long it took humans to develop the ability to digest certain types of proteins. Okay, for bacteria, it took only a couple of decades. For humans, it took a couple of thousand years or so, which only goes to show the difference here. Anyway.
New variations of the species are possible, but a new species has never been developed by science. In fact, the most modern laboratories are unable to produce a left-hand protein as found in humans and animals.
Okay, I'm not going to go into too much detail here because it's going to take too long, but basically, no, we can definitely produce proteins that are either right-handed or left-handed, depending on how we go about the procedure. This is called chirality, basically the idea that certain molecules can be so-called left or right-handed, and it has to do with an inversion at the center of symmetry of the molecule, basically. And so you can have amino acids that can be left-handed, which is the vast majority of amino acids in nature, or you can have amino acids that are right-handed, let's say. And amino acids, in turn, build up proteins. And yeah, actually, when we make a lot of amino acids, we usually end up with a roughly equal mixture of left-handed and right-handed amino acids. Now, for some reason, and we still don't fully understand why, but nature, in the sense that most living organisms on planet Earth use left-handed amino acids and don't use right-handed amino acids. Why there's a preference for left-handed amino acids in nature, we don't know. It's probably just a fluke. It's probably just that just is what happened to be used at first, and then it just sort of stuck. But yeah, we can definitely produce both left-handed and right-handed proteins. To say anything else is fundamentally ignorant and just wrong.
If selection were true, Eskimos would have fur to keep them warm, but they don't. In the tropics would have silver, reflective skin to help them keep cool, but they don't.
I really don't understand your point here, because it's just not true. The molecule that is responsible for protecting human skin from ultraviolet radiation from the sun is called melanin, and it's produced by your skin. And it gives you a darker tone. And in Central Africa, for instance, which is pretty much right at the equator, people are very dark. They have a lot of melanin in their skin to protect against the sun's rays. And their skin is almost black. So this idea that any other color would protect you better than just black, it's simply not true. I mean, have you ever seen a black person before? I'm serious. Like, have you looked at people from nations that are located very close to the equator. They are darker than fair-skinned Caucasians. Quite a lot darker. I really... I really don't understand how someone can be this ignorant. Anyway, I think that's enough. I think you all get the point now. This guy is full of crap, and I'm tired of it. Anyway, I'll see you in the next video. Bye!